Today, we're going to go over what is water. As a plumber, you're going to need to know what water is if you're ever going to be able to disinfect it or to treat it the proper way. So, water is hydrogen and oxygen added together equals hydrogen -2. That is the correct formula for water. The reason that this is -2 is because water is comprised of 2 diatomic elements, which there's only 7 diatomic elements in the world. They're all gases, and they are hydrogen, 2, chlorine, fluorine, bromine, iodine, oxygen, and nitrogen. These are the 7 diatomic elements of the world. They're all gases. What makes water so special is water is 2 diatomic elements added together, which form a solid state element. The reason there is a 2 beside all of these is because diatomic elements always come in pairs. You'll never see them alone. They have to have 2 in order to be. So, what happens when you add hydrogen and and oxygen together? Oxygen only needs, you end up with this. You end up with 2 hydrogen electrons and 1 oxygen electron to form. So, oxygen loses 1. It actually loses 2, which makes it -2. The reason that's important to know is once water is formed, it can stay in a glass for 100 years, and as long as it doesn't evaporate, it will never go back to its original state. Water will never turn back to hydrogen and to oxygen unless it's induced. The only way to convert it back to its original state is through electrolysis, which is one of the posts earlier, which is what happens in water heaters. It's when you introduce electricity into the water. What it does is it forces the electrons to separate, sending it back to its original form. And I've got an experiment here. I'll show you how that happens. So, what happens in a water heater is when electricity is introduced to it through an electric water heater, and it doesn't have to be that way. Electricity can be caused from friction in the pipes. It can be caused by static. It can be caused by heat. Can actually create a electrical current. Well, it's heat and pressure mixed. There's many different ways that you can get electricity into a system. So what it does is, here's the experiment that I've set up. And my battery's dead now, but it's done enough for you can see what it's happening. On the site right here is the water level on one side, and here is the water level on the other. This one is the hydrogen, this one is the oxygen. One of them's hooked to the positive, which is the hydrogen, and the negative is hooked to the one that's producing oxygen. The reason why you have twice as much hydrogen built up than you do oxygen is because when water was formed, you have twice as much hydrogen in the formula as you do oxygen. So, thus you have more hydrogen when it's reconverted. So, when you one of the tall tale signs that you're experiencing electrolysis, when you open your faucet and a burst of air comes out first, that is the hydrogen. That is because hydrogen is lighter than oxygen. So it's going to travel upward into your plumbing system, and it'll be sitting right there at the valve waiting to come out. That's one sign that you can tell that you have electrolysis. The oxygen, on the other hand, is what eats up metal when it comes in contact with it. So that's why in a water heater, we have an anode rod that dips all the way down into the tank. An anode is a piece of metal that has a positive charge to it. The reason it has a positive charge to it is because oxygen already has a negative reduction number. So, which means it's going to have negative ions in it. Positives and negatives attract. So we want to attract the oxygen to the positive charged rod so that the oxygen will oxidize this rod and break it down first before eating the steel tank. Once this is gone, once it starts eating the steel tank, that's when you'll get brown, rusty water because you've got a surplus of iron in it. Now, the reason that electrolysis is even able to occur, which is the same reason that water is conductive. We've always learned in school, don't put a bare electrical wire into water with it plugged up, you will get electrocuted. And the reason that is because water has many electrolytes attached to it, meaning electrical conductive matter like irons, magnesiums, even sodium. All of these are electrical conductors that are in the water. That's what gives it its conductive properties. However, distilled water or pure water, distilled water is the only pure form of water in the world, doesn't have any electrons in it. I mean, not electrons, electrolytes. It has no metals, it has no irons, no zincs, no magnesium, not even any sodium. It's pure. Therefore, it's non-conductive. So electrolysis cannot happen in pure distilled water. As a matter of fact, you can even take a bare electrical wire and stick it in a bottle of distilled water and plug it in and nothing will happen. That being said, being this is the last lesson that we'll be able to give this semester, I wanted to leave y'all with something positive. Now, I'm not a scientist by no means, so I'll only explain to you what I know. I know that normally H2O has a pH of 7. That's surface water, that's groundwater, and our bodies are made up of, over half of our bodies are made up of water. That's why our pH level is 7. That's the standard, which is called a basic. Anything that is 7 or higher is a basic pH level. Anything that is below 7 is acidic. Now, distilled water starts out at a pH of 7 when it is contained. However, when it's open to the air, our atmosphere is made up of hydrogen and nitrogen. And a byproduct of hydrogen and nitrogen is carbon dioxide, and which our plants breathe in through photosynthesis, breathe in carbon dioxide and release oxygen. That's how hydrogen, since it's already in the atmosphere, is able to bond with oxygen to make water. So distilled water, when it's open to the air, it will absorb the carbon dioxide. Now, the coronavirus, like every other virus in the world, it has to have three things. It has to have a source, it's got to have a transmission, and it's got to have a host. So, a virus has to start somewhere, then it has to be transmitted to somewhere else. And water is always the simplest, easiest way for any virus to transmit. And in times of crisis, we forget a lot of times the obvious. Everything in the world requires water. Everything. I don't care what it is. Everything requires water to survive, period. Therefore, it's the easiest mode of transportation for any viruses. Viruses can live, they can attract to water because water has electrolytes in it for the virus to attach to, like irons, sodium, magnesium, zinc. There is foreign matter in the water that allows viruses to attach to. And they have the correct pH level, like our body. Now, most viruses won't be able to reproduce in water, but they will be able to travel in water. Most of them will only be able to reproduce once they enter into a living host, whether it be an animal or a human or even a plant. But that being said, distilled water, however, once it's open to the atmosphere, has a pH level of 5.8. That's because of the carbon dioxide that it absorbs. That being said, 5.8 is highly acidic. Therefore, a virus cannot survive in distilled water because it's too acidic. It will die. So I'll leave you with this information, because if there's anyone out there that can use this information to help them prevent getting this virus, or to help develop a cure or something for it, the way to start is in water. That is the key and the answer to all of the universe's secrets of life is through water. So just remember, pure water is non-conductive, and it's also acidic, meaning it cannot act as a mode of transportation for viruses.